So very good morning, everyone. We will wait for 1 to 2 minutes so that someone will join, and then we will start our session. Okay, we will wait for 1 to 2 minutes so that someone will join. Then we will start. Okay, wait for 2 3 minutes. We will wait for 1 to 2 minutes so that someone will join. Then we will start. Wait for 2 3 minutes, right? Isn't it? Okay. So now start for the session. So in the previous lecture, we will discuss about the various corona effect due to the certain breakdown process. Okay, so we will directly go to the screen share section so that you will able to see, right? So this thing. Okay. Okay, fine. So, okay. So, in the previous lecture, we will discuss about the two things, right? The first of one is a first of one we will discuss about the breakdown of a this portion, the breakdown of a stable star corona and the breakdown of a stable and the leader corona, right? So these are the two things we will discuss today. Okay, so the few things that we'll discuss in the previous lecture, that means tomorrow, yesterday. Okay, so the breakdown, how the breakdown for the suitable star corona will be taken into consideration, that thing we will discuss. Okay, so we will also discuss what will be the different type of variation of a field intensity if we will considering the star corona and if we considering the steamer corona, right? So depending upon what type of electrodes you are using, depending upon that my discharge the nature of the discharge, that will be considered, right? So here we will see that we are considering the needle corona, right? And here we will see there will be the rod plate corona, right? So in the previous lecture we will discuss about the variation of the field intensity, where E is your actually your electric field. Okay, electric field intensity. So in this previous lecture we will discuss about the variation of the field intensity and the rod plate electrode configurations, right? So these are the all those characteristics we will discuss in the previous lecture. This things is also been discussed about the DC breakdown voltage characteristics, right? So this characteristics car will be the relationship between the gap distance D versus my breakdown voltage. Okay, obviously my dc breakdown dc breakdown voltage, right? Okay, so we will also discuss the few things in this particular part, right? And now we will discuss the thing of a similar characteristics. Okay, some characteristics which will be related to my steamer corona, right? So here it should be written that the characteristics, okay, we will measure for the negative polarity. So previously we will discuss about the positive polarity, now we will discuss about the negative polarity, right? So negative polarity, we will discuss about the negative polarity. So in case of a negative polarity, what will be the cases for the point plate electrodes if we consider the point plate electrodes? If we consider the point plate electrode, so for that case, point plate electrodes with a DC with a different gap length by Kuffel. Okay, Kuffel is a one scientist. Hufel is a one scientist who will develop this steamer theory. Okay, who will develop this steamer theory, or we can say that the steamer corona. Right, he will observe these things, right? So, if we considering the point plate electrodes, it is reported to have a particular radius of or del R of we can say that 0.66 mm, right? So below the lower curve we will see the conduction current that will measure. So in this figure we will see there will be the relationship between this particular characteristics curve. This particular characteristics curve will be the relationship between your DC voltage, okay, DC voltage versus your gap distance, right? Your gap distance, right? So the DC voltage is obviously my negative value versus my gap distance, which will be considered as a D. Here we will see at a very small gap distance, supposed to be having a radius of a having a very small radius, which will be considered as a 0.06 mm, or we can say that the del R is equals to 0.06 mm. So for that case, For that cases, what will be my breakdown and how this breakdown will be takes place, that thing. So due to this certain breakdown, what will be my VP? Due to my certain breakdown, what will be my V peak? That should be your 20 kV per centimeter, right? This thing. Okay, so this will be the breakdown characteristics. This thing, that will be your breakdown characteristics, right? So, and this equation and this particular characteristics curve will be for the transient region, because when we will see this particular region, having a gap distance of 6 centimeter. Okay, so for that cases, what will be my voltage, V peak voltage, which will be negative, which will be the negative voltage, supposed to be minus 60 volt or minus 65 volt, whatever it is. So in this particular region, we have a value of V peak. Okay, so this will be your line voltage, right? So the peak voltage, that should be comes to 20 kV per centimeter, depending upon my what the values of D is, right? So, and this portion, we can say this portion will be considered as a glow section. Okay, here we will consider the breakdown portion, and here it will be the transient region, right? It should be named termed as a transient region. Okay, so in this case, in this portion, up to this portion, this will be called my transient. Okay, my transient portion. So during this transient portion position, my VP should be minimum. Okay, that will depends upon my D. Okay, that will, so if I increase the gap distance, what we will observe in this particular characteristics curve, that it will again goes to the breakdown process. Then again it will go to the breakdown process, having a value r values of 0.06 mm. Okay, so that characteristics curve will be signify the DC negative point plates breakdown, and the corona discharge characteristics, how the corona that will discharge during the transient. Okay, having a medium of atmospheric air, that thing will be developed by a scientist who fell by a scientist who fell. Right. So in this case, so we will see that the breakdown with a stable steamer corona. So all those characteristics will be deals with the what? Deals with a steamer corona. Sorry, not the steamer corona. It should be the stable star corona. Okay. So all the characteristics equation that should be we will consider in the previously, that thing will be for the star corona. Right. So now we will discuss about the breakdown for the breakdown with a steamer corona, right? So in case of a steamer corona, what is happen? So in this particular cases, here we will see that this particular equation, or this particular figure, that will explain the breakdown mechanism developed with a stable steamer discharge, right? So if we have this is actually nothing but a energy developed, okay, due to breakdown, right? Energy developed due to breakdown, right? So in this particular cases, what we will see, said it will be written that as described in the earlier lecture, when we will basic requirement of the field intensity, the distribution gap is made, the steamer and the canal discharge. So already we will discuss this thing. So the avalanche with the above critical amplification inception, okay, or raising the applied voltage, and this steamer propagate the main field direction towards the opposite electrodes. So beside the streaming, the radius of the directions also shown in this particular figure. Okay, so here we will see that there must have the spark breaking arc. So if we will considering this particular electrodes over here, which will be my positive electrodes. Okay, so for that cases, this this thing, suppose this will be your spark distribution arc 1, this will be my spark distribution arc 2, this will be my spark distribution 3, this will be my 4, this will be my 5, this will be 6, this will be 7, and this will be 8, and that distribution, that should be n number of spark distribution, and this particular thing, that will be my spark distribution arc. Okay, so this will be my spark distribution arc, how the spark will be distributed, right? So in this particular case, what we will see, the impact of a photoionization effect that will be takes place, and which may be stable or unstable. So in this portion we will see that my arc proportion, my, that means my breakdown arc, that should be my steamer breakdown, it should be steamer breakdown. And what will be the impact of this spark? So impact, due to this impact of this spark, the photoionization process will be takes place, and which have a stable operation, right? So in this process also we have a impact ionization of a, or the impact photoionization will be taken into consideration, and there also there must have a stable operation. Okay, so in this case also, so up to this portion, that means number 1, number 2, and the number 3, so all this spark breakdown arc, all those spark breakdown arc having a stable operation, and the impact ionization process due to the steamer breakdown, right? So after this, the number 4 spark breakdown arc, this particular breakdown arc, this one, so this particular breakdown arc, okay, which will be have a branch streamer. So there will be the several branches, the number of branches in this streamer corona or the streamer discharge, we can say. So there must have a bunch type of structures. Okay, so it should be also be called as a bunch, bunch streamer, right? So here there will be the effect of a, here we can see there will be the effect of a cathode, right, not the anode. Okay, so in this case we will have a unstable operation will be taken into consideration, as because there will be the n number of branch, so whenever it will be goes to the needle or needle, then it would have been neutralized, it would be neutralized. So this particular operation having a spark breakdown arc in a number 4, there should be in a unstable operation. So from the 4 to 5, 4 to 6, so there must have, so here we will see, so there will be the pin type of structure, so there must have a pin type of structure, so the whatever the arc that will generate the unstable operation, right? So in this particular cases also the same operation will be taken into consideration, but at the spark breakdown arc at the point of 7 and 8, we will see, following this particular graph, we will see that there must have a certain variation due to certain operation of a particular breakdown arc. So here it should be known as a, this particular operation will be known as a leader. Okay, leader corona or the leader discharge, we can say, right? So it can be, and this particular, in case of a leader corona, we have an observe that the thermal ionization process that will be taken into consideration. But in case of a star corona, we will say that we have a impact of a photoionization effect. But in case of a leader corona, we will consider the ionization process having a thermal ionization process, right? So that should be my thermal ionization process, so that thing, so this particular characteristics or this particular photograph will be signify the breakdown mechanism that should be developed with a stable steamer discharge. Keep in mind these things, this term, a stable steamer, discharge. So after this, is there any confusion, anyone? Up to this, is there any confusion? Then we will start the next characteristics, right? So we can say that the any analytical explanation that will be inbuilt in this mechanism has to be described in a very difficult manner. So, however, in for distinguishing between the breakdown with a stable and the unstable streamer can be made in terms of a degrees of uniformity of the field, and the degrees of the uniformity can be defined. Okay, so the degrees of uniformity can be defined in a such a way that we can differentiate the breakdown of a stable steamer, or we can it should be the unstable steamer. So depending upon the breakdown process and depending upon the degrees of uniformity in a electric field, because in this particular cases, because we have to analyze this thing. Okay, so whenever, so where this particular leader corona that will be considered, and in case of a leader corona, what will be my thermal ionization effect that will be taken into consideration. And in this particular cases also, if we will consider the star corona, so for that cases also, what will be my impact ionization process will be takes place. So in case of a star corona, we will observe there must have a impact of a photoionization effect, right? So depending upon the various type of effect, corona effect, we have seen the various ionization process will be taken into consideration. Suppose in case of a leader corona, we have a thermal ionization process. In case of a streamer corona, we have a we have a photoionization process. In case of a star corona, we have a impact ionization process, right? So in this case, so we will see that for the analytical expression or analytical expression, so we have to distinguish between the breakdown with the stable and the unstable streamer. So we have to distinguish between the stable versus unstable unstable steamer, depending upon which value, depending upon the degrees of uniformity. Okay, okay. So depending upon the my degrees of uniformity, we have to distinguish between my stable steamer discharge and my unstable steam discharge. Okay. So we will consider, if we will consider the breakdown, considering the figure, if we will consider the breakdown when this one is greater than or equal to tau mean. Okay, so epsilon mean limit that should be considered. Okay, so the breakdown voltage for the region A, so the region A that should be considered in a figure 11.2 to 13 চলে গেছে. Okay, so what we can observe, this particular equation we will observe in the previous lecture, that ub, that means the breakdown voltage, okay, that must be my eb max into the distance, gap distance, into the slim, right? So that equation will be signified the equation of a breakdown voltage, right? Okay, at a particular region, at a particular region, right? So if we have a breakdown voltage, so when we have considering the another region, supposed to be, if we have considering the region B, if we will considering the region B and the previous region that should be considered as a region A, region A and the region B. So for that cases, in the region B, the equation should be UB is equals to E of B into D. So there may not be, so for that cases, this mu will be very less, is very less. So due to that, we will not considering the mu, but in this case, we will considering the mu because the mu value have a higher value, mu have a higher value, right? So we can say that, or we can say that EB, we can consider here also the EB max. So we will consider this one as a ES, where ES we can consider, ES is actually nothing but a average potential gradient. It should be called as a average potential gradient, right? Which will be required to break down a stable streamer. These things which will be required to break down a stable streamer. This one, which will be required to break down a stable steamer discharge or across the steamer channel, which is about. Okay, so what will be the values of ES? Okay, for breakdown the steamer corona. Okay, or the steamer discharge. What will be the values of my voltages? Obviously, the voltages is actually 4.5 kV per centimeter, right? For the positive polarity voltage, obviously. Okay, for the positive polarity voltage, and round offly if I consider, supposed to be, it should be 5 kV per centimeter at a positive polarity. Okay, so at a positive polarity voltage. So if we have to simplify these two equation, this equation and this equation, so we can consider the values of 25 kV centimeter. So equating, so it should be written that equating the two equation gives above and considering the values of 25 kV. Okay, so if I consider the 25 kV per centimeter, that means we are increasing the values of ES, okay, for breakdown with a stable steamer distance. So in this case for EB max, if we consider this particular values of ES, so what will be my EB max? Okay, so EB max is actually nothing but a my maximum breakdown, my maximum breakdown field intensity, right? So what will be the condition for the EB max? Okay, so in a year, obviously the medium is obviously the year. Okay, in a weakly non-uniform field, so the values of mu lim for the atmospheric condition can be determined as a this equation. So if I consider UB max into D into a, that is equals to ES into D. Okay, so if we simplify these two equation, so these two are same, right? So what is written, that it should be EB max into D into this limb, that is equals to ES into D, right? So D will be cancelled out. Okay, and what will be my this limb? That is actually your ES divided by EB max, right? So if we put the values, so what will be my del lim? That should be my ES divided by EB max, right? So if we put the values, so what will be my values of ES? Supposed to be 4.5, right? And what will be my values of EB max? That should be, this will be the maximum breakdown field intensity for a particular breakdown. So here it will be goes approximately 0.2, right? So using these two equation we can find the values of this min. Okay, so this limb is coming with how much? This means 0.2, right? So this particular characteristic scar that will signify the relationship between the gap distance, the relationship between the gap distance D and whatever by value of UB, right? That means breakdown voltages. So that particular relationship will be taken into consideration in this figure. Here we will see at a certain values of D, supposed to be whenever the values of D is equals to 0.5 centimeter, right? So for that cases, what will be my values of UB? What will be my values of suppose 250 volt, right? So at a when I increase the increase the distance, gap distance, okay, so it will see that the values of ub is also been increased. It's supposed to be, should be 400 volt. That means d is the distance, or we can say that the breakdown voltage that should be directly proportional to d. Whenever we have to increment of the distance, gap distance, then there will be the certain values of the ub will be increased. Okay, so in this case, okay, one second. Here you will see. No, no. Okay, so here you will see that there will be have a characteristic curve. This will be the characteristic curve of a the relationship between UB versus my D. Okay, the gap distance. Here we will see at a gap distance D is equal to 1, D equal to 1. So we will see the values of UB, that should be my 400. At the values of D is equal to 2, you will see that my values will be supposed to be UB is supposed to be 900, right? So the 900, right? So at a values of d is equal to 4, so what should be my breakdown voltages? That should be supposed to be ub, that is equals to 1200 kV, right, at a gap distance of 4 centimeter, right? So if you increase the values of d, then your vb that is also been increased, or ub that is also been increased. So if we connected all those lines, okay, so it have considering this particular characteristic curve. Okay, so if we stretch this particular line and this one, it will comes at a very small amount of voltages, which will be considered as a del v, which will be termed as a 1 kV per centimeter, right? And here it should come the time duration for considering this particular voltage, that should be my 4.5 kV per centimeter, right? Okay, so in this particular case, here there will be the consideration of a steamer breakdown. So in case of a steamer breakdown, we have given the voltage of we have given the voltage of 400 kV. So what will be the effect? Okay, so if we consider, so 400 kV, or we can say that the it should be considered as a 4.0 kV per centimeter, having a gap distance of d. Okay, so that should be, if we applied the voltage of 1180 kV, 1180 kV, so what will be the effect? So that thing, so up to this part, it will be considered as a leader corona. So after this, it should be considered as a steamer corona, right? It should be written that. Okay, so that thing we will discuss today. So this particular figure, it will be considered as a relationship between. It will be considered as a relationship between the breakdown voltage characteristics. That means breakdown voltage, which will be UB, right? Breakdown voltage characteristics and mean potential gradients required for the propagation of a stable steamer, and as well as the leader corona, steamer corona, and as well as the steamer corona. If I applied the voltage of 40 kV, so there must have only the steamer corona. But if we considering the voltage applied to the particular section, that should be 1180 kV. So for that cases, it will up to this. Okay, it will be my leader corona up to 1 kV per centimeter. But after beyond 1 kV per centimeter, it should be termed as a steamer corona, right? So this portion will be considered as a leader corona, okay, and this portion will be considered as a steamer corona. Is it clear? Okay, let me check. So, is there any confusion? Anyone told me? Do you have any problem? Yes? Just tell me. Anyone? Yes, anyone? Okay, I think no one. Okay, so we will stop the session for today. We will discuss the breakdown with a stable steamer and the leader corona in the next class, right? So these things we will discuss in the next lecture, right? So the breakdown with a stable steamer with a leader corona. Then we will discuss some basic breakdown characteristics. Okay, first corona, steamer corona, leader corona, and the final jump. How that will be considered. So this will be my steamer corona or the first corona. Okay, and this will be my final corona effect that will be considered, right? So that thing we will discuss in the next lecture. Okay, so this lightning, so that thing will be my that thing will be my first corona effect, right? First corona. Okay, and that thing will be my leader corona, right? Okay, so in between this, whenever it should come like this, whenever it should come like this, whenever it should come like this, so up to this portion we will consider it as a steamer corona, right? So this thing we will discuss in the next lecture. Okay, thank you. So we will stop the session for today. Thank you very much.